You know, some of the biggest disasters in tech don't start with some huge dramatic explosion or a super sophisticated cyber attack. Nope, they often start with something really small, something that looks completely harmless. So let's get into the story of how one single command became a weapon of mass destruction for an entire storage cluster.
All right, take a look at this. It looks like a totally standard curl command, right? The kind of thing a sysadmin might run a dozen times a day without even thinking. It's just asking the system for some basic stats. But hidden inside that simple request, in that tiny little parameter, detail equals 1, was a catastrophic flaw. That right there, that is the poison pill at the heart of our story.
And believe me, I am not exaggerating here. That one seemingly innocent API call triggered a complete and total system meltdown. This is the story of exactly how it happened, how it was fixed, and maybe most importantly, what it teaches us about just how fragile these complex systems we rely on really are.
Okay, so let's set the scene. Picture this. 1 minute, you've got a perfectly healthy, happy storage cluster just humming along, doing its job. It's the backbone of a whole virtualization setup. The very next minute, after running that one little command, everything is dead. And I mean dead. Not slow, not glitchy, completely, totally offline.
It was like the worst domino effect you could possibly imagine. The storage goes dark, and bam, every single virtual machine that depends on it just freezes solid. The management dashboard? Oh, it's just a sea of red alerts. You know, the universal sign for, we are in very, very big trouble. All the core storage daemons, the workhorses of the cluster, offline. It was a complete, system-wide catastrophe. So, in the middle of all this chaos, the first real clue finally pops up in the system logs. Now, I know this looks like a bunch of technical jargon, but just focus on the very end. Bad or missing field detail. That right there was the smoking gun. The system literally choked on that one little parameter from our original command and crashed. But that still doesn't explain why it was so devastating, right? Why did it take down the entire cluster? And this is where things got really weird. The admin discovered that running the exact same command, but directly on the command line, Ceph def detail, it worked perfectly, no issues at all. So the system's internal logic was totally sound. The failure was happening specifically and only at the REST API layer, the automated gateway that's supposed to make things safer and easier.
See, this wasn't just a simple one-and-done crash. The cluster had been tricked into poisoning itself over and over and over again. And that self-inflicted wound turned out to be fatal, all because of how the cluster's brain is designed to work.
To really get what happened here, you have to understand the role of these things called Ceph monitors, or MONs for short. Just think of them as the brain of the entire operation. They know where every piece of data lives. They keep all the other parts of the cluster in sync. They're the central nervous system. So you can probably guess what happens if the MONs go down. The cluster is basically brain dead. It has no memory, no coordination, nothing.
Okay, so check this out. Here is the 3-step process that created a literal death loop. It all starts right here with our one bad API call. That malformed request with the detail equals 1 parameter hits the system.
Now, this is the critical point of failure. Instead of the API layer recognizing this input as invalid and just rejecting it, it just let it right through. And what's worse, the command was then written into the shared database that all the monitors used to stay in sync. The poison was now officially in the bloodstream.
And here's the final, brutal step. A monitor would start up, read that shared database to get the latest state, encounter that poison pill command, and immediately crash. Then another monitor would try to take its place, and the exact same thing would happen. The cluster was stuck in a reboot loop from hell, constantly feeding itself the very command that was killing it.
The administrator, who goes by the name Packetsar online, summed it up perfectly. A single, authenticated REST call was enough to corrupt the shared state of the entire system and create a persistent failure that couldn't be fixed with a simple restart. That is a terrifying vulnerability.
So, with the cluster completely unresponsive and stuck in this death loop, the focus had to shift from diagnosing the problem to a high-stakes manual recovery operation. This was the central question. You can't just reboot. You can't just restart a service. The brain of the cluster itself was corrupted. The only way forward was to perform what was basically the digital equivalent of a brain transplant, rebuilding the entire monitor database from scratch.
And let me tell you, this was not a simple procedure.
This was a nerve-wracking, step-by-step manual rebuild, the kind of thing you only find deep in the system's documentation for absolute emergencies. It meant shutting everything down, carefully extracting data from the healthy parts of the system, and then manually copying that clean state back onto the monitor nodes to replace the corrupted files. I mean, one wrong move could mean total data loss. No pressure, right?
And what is just incredible is that after starting this complex and risky procedure, the admin had the virtual machines back online in about an hour. 1 hour! That is just wow. It's a huge testament not just to great documentation, but to incredible skill and composure under pressure, from total meltdown to operational in just 60 minutes.
This entire incident, from the crash all the way to the recovery, offers some really powerful lessons for anyone who builds or manages complex systems. So, what can we all take away from this?
Well, first, APIs are not some magic shield. Without rigorous input validation, they can become a fragile single point of failure. Second, a system's ability to save its state, its persistence, is a double-edged sword. It's great for resilience, but it can also make a bad state permanent. Third, and this is a big one, testing even a small thing in a live production environment isn't really testing, it's gambling. And finally, never, ever underestimate the power of good documentation. It's not just for learning, it's a survival guide.
Zooming out, this story illustrates a fundamental truth about modern infrastructure. We build all these layers of abstraction and automation to make things simpler, but each new layer we add, whether it's an API or a management tool, also introduces new and sometimes totally unexpected ways for things to break.
And that really brings us to this core idea. A system like Ceph is incredibly powerful and flexible, but that power comes with immense complexity. And, as this incident shows so clearly, that complexity always comes at a cost. The trade-off for power is fragility.
So I'll leave you with this question to think about. Look at the systems you use or manage every single day. Think about all the automated scripts, the API calls, the simple commands you run without a second thought. How many of those does your system implicitly trust? And what would happen if just one of them was secretly a poison pill?